So, before I leave off today, I want to take you through a couple questions in naming alcohols and drawn alcohols. So, if we look at our first compound here, our first step in naming alcohols is identifying our root. Our root is the parent alkyne, or the longest chain of carbons that includes the hydroxyl groups. So, if we look at the compound here, we are lucky enough to notice that there's only one chain and there are 4 carbons in it. So, there are 4 carbons in chain. And since we know that there are 4 carbons in the chain, we know that the parent alkyne, or the root, will be butane. We know this because butane is made up of 4 carbons. So, before we move on to step 2, we want to remember to do our mini step, in which that is we want to number our carbons in the chain so that the lowest numbers are next to the hydroxyl group. So, if we look at this compound, we notice that the hydroxyl group is on the right side. So therefore, we want to number our carbons 4, 3, 2, 1, so that the lowest numbers are near our hydrogen, or our hydroxyl group, sorry. Our next step is identifying our suffix. So, we want to look where our suffix is and which carbon atom it is bonded to. So, if we look at our compound, the hydroxyl group is bonded to carbon atom 2. So therefore, our suffix is going to be -2-O. And remember, it's only one O because there's only one hydroxyl group. Our next step was identifying the prefix. But if we look at our compound, we notice that all the atoms or all the elements are already being used, so that means there is going to be no prefix. The final step in naming alcohols is combining the root, the suffix, and the prefix to name your alcohols. So therefore, the name of this compound right here will be butane -2-O. And remember, we omit the E at the end of the parent alkyne because the suffix started with a vowel. So, the next question we want to do, 76. Alright, so 76. So, our first step is we want to figure out our chain, and if we look at our compound, there's only one chain, so there's 1, 2, 3, 4, 5 carbons in our chain, and this means that our parent alkyne is going to be pentane. We know this because pentane is made up of 5 carbons, and there are 5 carbons in our chain. Our next step, or our mini step, is going to be numbering the carbons in the chain so that the lowest numbers are next to the hydroxyl group. So parent alkyne equals pentane. And then we want to number our carbons, so 5, 4, 3, 2, 1. Lowest numbers are near the hydroxyls. So then, after we have numbered our carbons in the chain, we want to next identify our suffix. So, if we look at our hydroxyl groups right here, we'll notice that they are numbered to carbon atoms 3 and 2. So, therefore, our suffix is going to be -2, 3, diol. And remember, it's going to be diol because there are 2 hydroxyls in it. And when we are numbering our suffix, you want to go from least to greatest for the numbers. So our next step is identifying our prefix, but if we look at our compound, we'll notice that all the elements are already being used, so that means there are no prefixes. And now we can name our compound since we know the parent alkyne, the suffix, and that there is no prefix. So therefore, the name of this compound is going to be pentane with the E, because remember, this began with not a vowel. So pentane -2, 3 diol. And there's number 76 for naming alcohols. Alright, drawn alcohols. So if you remember, the process for drawn alcohols involve 5 steps. And the first 2 kind of go hand in hand. So the first thing you want to do is identify the root of the alcohol. And if we look at the alcohol that's given, we'll notice that ethane is our root, or the parent alkyne. And since we know ethane is made up of 2 carbons, we know that there are going to be 2 carbons in our carbon chain. And so because of this, we can then draw our chain. And then we want to number our chain from left to right. 1, 2. So after those first 2 steps, we want to next identify our suffix. So if we look again at the name, we'll notice that our suffix is ol. Now, an important thing to know with suffixes is if you ever see a suffix like this where there's no number in front of the ol, it is automatically assumed that the number is going to be 1. So -1 -ol. And since there's only 1 ol, we know that there's only going to be 1 hydroxyl group in the alcohol. So now that we know our suffix, it's on 1, we can draw our hydroxyl group on the first carbon. Our next step is identifying the prefix. And if we look at our alcohol, we'll notice that there are no prefixes given. So our final step in drawn alcohols is we want to add enough hydrogens to each carbon atom in the chain so that there's 4 bonds. So add hydrogens to make 4 bonds for each carbon. So therefore, since the first carbon already has 2 bonds, that means 2 hydrogens will go along with it. So now it does have 4 bonds. The second carbon only has 1 bond, so therefore it will need 3 hydrogens to make it have 4 bonds. And this right here is your final alcohol or product, which is ethanol. So the next question for 81 is going to be propane-1-ol. And once again, we want to do the first step, which is identifying our root, which is propane. And since we know propane has 3 carbons, or is made up of 3 carbons, then we know there are going to be 3 carbons in our chain. So we can then draw our chain. So 1, 2, 3 carbons and number it from left to right. So 1, 2, 3. And then after that, we can then look at our alcohol again to identify our suffix. So our suffix is once again going to be -1-ol. And this means that there is going to be 1 hydroxyl group because it's only 1 ol on the first carbon atom, which we can then draw here. So after we've drawn our suffix, we can then identify our prefix, but if we look at our alcohol, we'll once again see there is no prefix. So after we identified the root, the suffix, and the prefix, we can then add enough hydrogens to make each carbon bond or to make each carbon atom have 4 bonds. So if we look here, this already has 2 bonds, so therefore it has 2 hydrogens. This already has 2 bonds, so therefore it gets 2 hydrogens. And this has 3 bonds, or has 1 bond, so it gets 3 hydrogens. And that is how you draw alcohols.